They say fire is the hottest thing in the universe. But what if I told you the most extreme place we know isn't blazing, it's freezing? Not just cold, not winter cold, not Antarctica cold. I'm talking about a temperature so low that atoms almost completely stop moving. A place colder than deep space itself. And yes, it's real. Right now, as you're listening to this, the coldest natural temperature ever recorded in the universe is about minus 272 degrees Celsius. That's just 1 degree above absolute zero. Absolute zero is minus 273.15 degrees Celsius, or 0 Kelvin. The theoretical point where atomic motion nearly stops completely. And the shocking part? We found this place not in some distant galaxy, but inside our own Milky Way. The Boomerang Nebula. Located about 5,000 light-years away in the constellation Centaurus, the Boomerang Nebula holds the record as the coldest known natural place in the universe. Its temperature has been measured at approximately 1 Kelvin. That's minus 272 degrees Celsius, colder than the average temperature of outer space itself, which sits around 2.7 Kelvin due to leftover radiation from the Big Bang. Let that sink in. Deep space, the vast emptiness between stars, is warmer than this nebula. Now here's the pattern interrupt. Space is not supposed to be that cold. Nothing naturally cools below the cosmic microwave background radiation, which fills the universe at 2.7 Kelvin. So how did this nebula break the rule? The answer is both violent and beautiful. The Boomerang Nebula is a dying star system. At its center is a red giant star nearing the end of its life. As it sheds its outer layers, it ejects massive amounts of gas at incredibly high speeds, about 164 kilometers per second. That gas expands so rapidly that it cools dramatically in the process. This rapid expansion causes what's known as adiabatic cooling, the same principle that makes a spray can feel cold when you use it, but on a cosmic scale. Because the gas is expanding faster than surrounding radiation can warm it, it drops below the temperature of space itself. In simple terms, it's creating its own deep freeze bubble in the cosmos. NASA's Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, known as ALMA, have studied this nebula in detail. In visible light, it resembles a faint bow tie, but in radio wavelengths, we see the true extent of its ultra-cold gas cloud stretching far beyond what optical telescopes reveal. Now here's where things get even more fascinating. While the Boomerang Nebula is the coldest natural place ever discovered, humans have actually created temperatures even colder, right here on Earth. And this is where the controversy begins. In laboratory conditions, scientists have cooled atoms to temperatures just billionths of a degree above absolute zero. In 2021, researchers working with ultra-cold quantum gases achieved temperatures in the picokelvin range, trillionths of a Kelvin. That's dramatically colder than the Boomerang Nebula. So technically, the coldest place in the known universe isn't in space. It's inside physics laboratories. Using laser cooling and magnetic traps, scientists slow down atoms until they barely move. At these temperatures, matter behaves in bizarre ways. Atoms merge into a single quantum state called a Bose-Einstein condensate. Instead of acting like individual particles, they behave like one giant superatom. Why would scientists want to create something so cold? Because extreme cold reveals the hidden rules of reality. Quantum mechanics, the physics governing the smallest scales, becomes visible in these conditions. Superconductivity improves. Magnetic properties shift. Time and gravity can even be measured with astonishing precision. Ultra-cold research is helping scientists develop quantum computers, ultra-precise atomic clocks, and new materials that could transform technology. But let's return to space for a moment. You might think Antarctica would compete for the coldest place title on Earth. The lowest natural temperature ever recorded on Earth was minus 89.2 degrees Celsius at Vostok Station in Antarctica in 1983. Satellite data has suggested even lower surface temperatures, possibly down to minus 98 degrees Celsius in certain East Antarctic ice pockets. And yet, Even at minus 98 degrees, Earth doesn't come close to the Boomerang Nebula's minus 272. Now here's something that might surprise you again. The coldest temperature ever recorded in our solar system isn't on Pluto. It's on the Moon. In permanently shadowed craters near the Moon's south pole, NASA's Lunar Reconnaissance Orbiter measured temperatures as low as 25 Kelvin. That's minus 248 degrees Celsius. These craters never see sunlight, making them some of the coldest known spots in our solar system, still warmer than the Boomerang Nebula. So what happens at absolute zero? Could anything actually reach it? According to the third law of thermodynamics, absolute zero can never truly be reached. As a system approaches absolute zero, removing the last bit of thermal energy becomes infinitely difficult. Scientists can get incredibly close, billionths or even trillionths of a degree above it, but never exactly 0 Kelvin. At absolute zero, atoms would theoretically stop all motion. Entropy would reach its minimum value. Classical physics would essentially break down, and quantum effects would dominate completely. But here's the twist. Even at absolute zero, quantum mechanics says motion never fully disappears. There's something called zero-point energy, a tiny residual motion that cannot be removed. So in a strange way, true, complete stillness may not even be possible in our universe. Cold, it turns out, is not simply the absence of heat. It's a boundary where the laws of physics start revealing their deepest secrets. And here's the bigger perspective. The early universe, moments after the Big Bang, was unimaginably hot, billions of degrees. Over 13.8 billion years, it has been cooling as it expands. One day, trillions upon trillions of years in the future, if the universe continues expanding, everything could approach near absolute zero in a scenario scientists call heat death. Stars will burn out. Black holes will evaporate. Matter will decay. The cosmos will become dark, cold, and nearly motionless. In a way, the Boomerang Nebula may be giving us a small preview of the universe's distant fate. From a dying star creating the coldest natural region ever observed, to scientists pushing atoms to trillionths of a degree above absolute zero, the pursuit of cold is more than a temperature record. It's a journey to the edge of physics itself. And here's the final pattern interrupt. Cold isn't the opposite of heat. Cold is the absence of energy, which means the coldest place in the universe is also one of the quietest, calmest, and most mysterious environments imaginable. A place where atoms barely move, where radiation struggles to penetrate, where a dying star accidentally broke a cosmic rule. So next time you feel cold air on your skin, remember, somewhere 5,000 light years away, there's a nebula so cold it makes deep space feel warm. If this expanded your sense of reality even a little, make sure you follow for more mind-bending journeys through science and the universe. Now I want to ask you, if we can already create temperatures colder than space itself, what do you think we'll discover when we finally master the physics at the edge of absolute zero?